Welcome back to the Deep Dive, where we unpack complex topics and get straight to the insights you need. Today, we're plunging into large language models, or LLMs, the tech behind powerhouses like ChatGPT. I mean, it hit 100 million users in just 2 months, which is just incredible.
It really is.
And these aren't just chatbots anymore. They're really changing how we work, helping draft emails, brainstorm, generate code, even create, personalized tutorials.
It often feels like magic, doesn't it?
Mhm.
But at their core, LLMs are fundamentally text completion engines.
Right.
They predict the statistically most likely next word or sequence of words, and understanding that core function is really key to unlocking their potential.
And that's exactly where our deep dive begins today. We're exploring prompt engineering, which is, well, the art and science of talking effectively to AI. It's about turning your ideas, your questions, your goals into a language the LLM can actually understand and act on, guiding it to generate the content you really need.
Yeah, exactly. Our mission for you, the listener, is to move beyond the basics. We want to show you not just what LLMs can do, but the how and the why behind getting them to perform really complex tasks.
Right.
We're drawing insights from, leading experts, people like John Berryman and Albert Ziegler, who co-authored Prompt Engineering for LLMs. They were founding engineers at GitHub Copilot, too.
Okay, so real practitioners.
Absolutely. You'll discover practical techniques today that go far beyond just simple instructions.
Great. And for this deep dive, we've pulled insights from a pretty rich stack of sources. We've got advanced prompt engineering techniques from Mercity AI, another advanced techniques piece looking towards 2025 from Reddit, the general tips for designing prompts from Prompt Engineering Guide, and of course that comprehensive book, Prompt Engineering for LLMs by Berryman and Ziegler.
So let's start with that foundational idea. LLMs are powerful predictors. When you give them a prompt, they're not thinking like humans do. They're calculating the most probable token, which could be a word, part of a word, even punctuation, based on the huge amount of text they've been trained on.
It's fascinating how we even got here. Early language models, they struggled with longer text, right? They
Yeah.
forget details as they process things sequentially.
Yeah, the dreaded information bottleneck.
Exactly. But then came the transformer architecture, the thing that powers GPT. And the breakthrough, as I understand it, was its ability to sort of pay attention to all parts of the input text at once, understanding the whole context.
That's it. It removed that sequential bottleneck. That's what truly ignited this whole AI revolution we're seeing.
In this unique way they process information, it means LLMs see the world very differently than we do.
Completely. They break text down into these tokens. So a typo, like ghost instead of ghost, it isn't just slightly misspelled to the LLM.
No.
It becomes entirely different tokens, maybe ghost or something. While they can often figure it out from context, it shows just how precise their internal view is. Careful input really matters.
Huh. It also means they have some surprising limitations compared to us. We instantly get visual things in text, like ASCII art, or that an accented E doesn't fundamentally change resume.
Right.
But for an LLM, processing those visual nuances or tasks that need precise letter manipulation within words like, say, reversing a word letter by letter, that can be surprisingly tough.
Yeah, they can't just slow down and look at the letters visually like we can. They expend a lot of processing power on things we find trivial.
So one really important dial we can turn when we interact with them is temperature, right?
Absolutely. Temperature dictates the LLM's creativity, or maybe how predictable its output will be. A temperature of 0 gives you the single most statistically likely token.
Right.
It's like asking for the absolute standard answer, the most probable completion based on the training data.
So if I need a precise factual summary, I'd want a low temperature like 0 or close to it.
Exactly. Keep it low for facts.
But what if I want something really novel, like for creative writing or brainstorming? Can I push it too far?
Oh, definitely. If you crank that temperature dial up, say towards 1.0 or even higher, like 2.0, things get much more adventurous.
Adventurous?
Yeah, higher temperatures lead to more stochastic, more random completions. Sometimes they can be chaotic, even nonsensical. The model becomes less likely to pick the standard path and more likely to explore less probable, often surprising tangents.
So it's a great tool for creativity, but you've got to manage the risk of it just going off the rails.
Precisely. You need to find the right balance for your task.
Now, to get reliable results, even from these super advanced models, there are some basic prompting rules we should probably cover. The Prompt Engineering Guide mentions putting your core instructions right at the start of the prompt.
Yes, that's crucial. And using clear separators like hashtag tag tag to your instructions in any context you provide.
Right.
For example, hashtag tag instruction, hashtag tag translate the text below to Spanish, then text hello.
Yeah.
Makes it super clear what's an instruction and what's the data.
Beyond just putting it at the start, how specific do we really need to be? Is it about finding some magic keyword, or is it more fundamental?
Well, it's generally not about finding magical keywords. It's much more about being very specific and detailed about the task and the format you want the output in.
Ah, the format too.
Yes, a well-structured prompt, maybe with good examples, is way more effective than just tossing in a few keywords. Providing a couple of examples of the input-output format you want, what we call few-shot examples, that's incredibly powerful. It helps convey those implicit rules the model might struggle with otherwise.
And here's one that seems counterintuitive but is really important. Focus on what the model should do, not what it should not do.
Oh yeah, the negative instruction problem.
Exactly. We saw that great example with a movie recommendation chatbot. If you tell it flat out, do not ask for interests, it often asks for interests anyway.
It's almost like it focuses on the ask for interests part.
Right. But if you rephrase it positively, like, it should refrain from asking users for their preferences, then it understands and behaves correctly. It's all about framing the intent.
Okay, so those are some good foundational rules. Now let's shift gears a bit and move beyond those basics to some of the more advanced techniques. These help LLMs tackle truly complex reasoning and even interact with the real world.
This is where it gets really interesting.
Yeah. Modern chat models like ChatGPT aren't just simple text completers anymore. They've undergone special training using human-crafted conversations. That's called supervised fine-tuning, or
SFT?
right, teaching it the conversational flow.
Exactly. And then there's something even more advanced, reinforcement learning from human feedback, or RLHF.
RLHF, okay. That's where humans actually rank different model responses.
Precisely. Humans rank responses from best to worst, teaching the model to align itself with human values, aiming to be helpful, honest, and harmless, often called HH aligned.
Helpful, honest, harmless.
Okay.
But here's a fascinating wrinkle. Sometimes this RLHF process, while making models polite and generally safer, can actually subtly decrease the model's raw intelligence or its usefulness for certain unfiltered tasks.
Really? How so?
It's a phenomenon known as the alignment tax. While it shapes models to be uniform and helpful in everyday chat, it can sometimes filter out what you might call raw humanity or make them less effective for highly specialized, nuanced tasks where maybe that unfiltered output is exactly what you need.
That makes a lot of sense. Like if I'm a doctor brainstorming really unusual diagnoses, I probably don't want a model that's too polite or worried about stepping on toes. I need its raw predictive power.
Exactly. You might want the less filtered, perhaps slightly less aligned output in that specific context.
And these chat models, especially with things like ChatML, they really formalize the conversation structure, don't they? Using specific tokens like imstart system and imstart users.
Yes, those tokens clearly define roles, making it unambiguous who is saying what. It's vital for complex, multi-turn conversations.
Okay, so that structure helps. What about enhancing the reasoning ability itself?
Great question. One of the simplest yet most effective techniques is chain of thought, or COT.
Chain of thought. Heard a lot about this one.
Yeah, it basically encourages the LLM to show its step-by-step thought process before giving the final answer. Since LLMs don't have, an internal monologue like we do,
Right.
asking them to think step by step essentially gives them the computational time or space to reason more carefully. It often leads to much more accurate results, especially for problems needing multiple steps.
So it's like giving them a virtual scratch pad to work out the problem instead of forcing them to leap straight to the answer. The sources had a good example, didn't they? Something about a number puzzle.
Yes, where a long step-by-step preamble led to the correct answer while just asking the question directly failed. So for you, the listener, if an LLM is struggling with a complex math problem or a logic puzzle, simply adding "let's think step by step" can honestly be a game changer.
That's a powerful, simple trick.
But we can go further. What's even more powerful for certain problems is tree of thought, or TOT.
Tree of thought. Okay, how does that differ?
It goes beyond the linear, step-by-step nature of COTI. TOT allows the LLM to explore multiple reasoning paths simultaneously, like branches on a tree.
Ah, so it considers different possibilities at each step.
Exactly. For complex tasks that require planning or search, think of games or intricate problems, TOT can be dramatically better. like the game of 24 example in the sources.
What happened there?
With TOT exploring multiple paths, it achieved a 74% success rate. Basic input-output prompting got only 7.3%, and even standard chain of thought only managed 4.0%.
Wow, 4% versus 74%. That's huge.
It's a massive difference. It tells us that for certain types of problems, forcing linear thinking just doesn't cut it. You need that branching exploration. TOT significantly boosted average GPT-4 scores on various tasks compared to COT as well.
That's incredible. But crafting those branching prompts sound potentially very complex and time-consuming for a developer. Is there a way to automate generating these reasoning chains?
Good point. Yes, that's where techniques like autocode come in. It automates the process of creating those chain of thought demonstrations.
How does it work?
It basically clusters similar questions together and then automatically generates reasoning chains for them. It's shown to consistently match or even beat the performance of manually created COT prompts because it becomes task adaptive.
Okay, so it learns the best way to reason for a specific type of question.
Exactly. And taking that automation even further, there's something called the automatic prompt engineer, or APE.
APE?
Yeah, this technique actually uses the LLM itself to find the optimal prompt wording that maximizes the chance of getting correct reasoning steps.
So AI optimizing prompts for AI.
Pretty much. For instance, APE generated the prompt, "Let's work this out in a step-by-step way to be sure we have the right answer." That specific phrasing improved performance on math benchmarks like multi-arith and GSM-8K, sometimes even surpassing human performance with models like InstructGPT.
That's wild, using the tool to sharpen the tool.
It is, and this all leads to another big question. How do LLMs actually act in the real world, beyond just generating text?
Right, how do they interact with things?
This brings us to techniques for external interaction and automation, often grouped under tool usage. Tool execution APIs essentially allow LLMs to make API calls, interact with external systems, check databases, browse the web, and bring real-world info back into their reasoning process.
So an LLM could effectively look something up or perform an action as part of figuring out an answer.
Precisely. One key method here is reason and act, or REACT.
Reason and act. Okay.
It combines reasoning, traces the step-by-step thinking with actual actions. The LLM first thinks about what it needs to do, then decides on an action, like making an API call, performs it, observes the result, and then continues reasoning based on that new information.
So it's a loop. Think, act, observe, think again.
Exactly. It enables really dynamic problem solving and higher level planning. It helps LLMs overcome things like hallucination because they can check facts, and it helps prevent errors from compounding. It showed big improvements on question answering tasks like Hotpot QA, and even in interactive text-based games like ALF World and Woodshop.
Learning from interaction. Then there's RT, automatic multi-step reasoning and tool use.
Right. RT is a framework that allows even frozen LLMs, meaning the base model isn't being retrained during the task, to automatically generate those intermediate reasoning steps and select and use tools from a predefined library.
So it figures out, okay, I need the weather API now, calls it, gets the data, and plugs it back into its thought process.
Exactly. It seamlessly pauses its own text generation to integrate the tool's output. It's enabled LLMs to solve tasks that were previously thought impossible for them without this tool integration.
That's powerful. And ReWO, what's the angle there?
reWO is interesting because it tackles efficiency. It decouples the reasoning part from the tool using part. It allows a larger, powerful LLM, like a big GPT model, to handle the high-level planning, but offload some of the detailed reasoning or information gathering to smaller, faster, cheaper models, like a Llama 7B.
So it orchestrates using different models for different parts of the job.
Precisely. It promises more efficient and scalable AI systems where you don't need the giant model running for every single step. It's very clever.
And right at the cutting edge, we hear about things like AutoGPT.
Yes. AutoGPT is an example of an autonomous AI agent. You give it a high-level goal in natural language, and it tries to achieve it by breaking it down into subtasks, autonomously using the internet, files, and other tools.
It figures out the steps itself.
Yes, and it can even create and revise its own prompts and manage its own short-term and long-term memory to learn as it goes. It's a glimpse into the future of AI agency, although, it doesn't always work perfectly for really complex, open-ended goals yet. It's still experimental, but very exciting.
Definitely sounds like the frontier. And for developers actually trying to build applications using these LLMs, there are frameworks to help, right?
Absolutely. Tools like LangChain are hugely popular. LangChain acts as an orchestrator, integrating LLMs with cloud storage, various APIs, web scraping tools, different databases, and multiple LLM providers. It makes connecting all these pieces much easier.
Kind of like the plumbing for LLM apps.
A good way to put it. And then there's Semantic Kernel from Microsoft. It's an open source SDK designed to let developers easily integrate AI services, like OpenAI models, into their existing applications written in languages like C# and Python. It provides concepts like memories for context and AI plugins for tool use.
So these frameworks are really crucial for bridging the gap between the raw LLM capability and building a useful product.
They really are. They handle a lot of the boilerplate complexity.
Okay, so we've covered some amazing things LLMs can do with the right prompts and tools, but how do we actually make sure they're performing well for our specific needs? How do we design and evaluate these applications effectively?
That's critical. Because at the end of the day, you need results. Think of an LLM application as working in a kind of loop.
A loop?
Yeah, there's a transformation layer. It takes the user's problem, which is in the user's domain, translates it into a prompt for the LLM's text domain, gets a text completion back from the LLM, and then converts that output back into a useful solution in the user's domain.
Input, prompt type completion, output tile solution. Makes sense.
And managing the context within that prompt is a huge part of this loop. It generally breaks down into static versus dynamic content.
Static versus dynamic. Okay, what's static?
Static content is basically the hard-coded text you put in the prompt that clarifies the general task. This includes things like defining a persona for the LLM, you are a helpful financial advisor, or specifying the exact output format, and importantly, providing those few-shot examples we talked about earlier.
Right, the examples that show the model what good looks like.
Exactly. Few-shot examples are incredibly powerful for conveying those implicit rules, the I know it when I see it type of information that's really hard to state explicitly in instructions.
But you mentioned a potential pitfall. Too many similar examples.
Yes, there's a risk. If you provide too many examples that are too similar or contain irrelevant details, the model might overinterpret them. It might assume every little detail is significant, kind of like the Chekhov's gun idea in literature.
Where if you show a gun in Act 1, it has to go off later.
Right. The LLM might see details in your examples and expect them all to be relevant, potentially creating connections or constraints that aren't actually intended. You need diversity in your examples.
Got it. So that's static context. What about dynamic?
This is where things get really powerful, especially with retrieval augmented generation, or RAG.
RAG again, okay.
So LLMs, out of the box, can't access information outside their training data. They don't know about recent news, your company's latest internal reports, or your personal emails.
Right, their knowledge is frozen in time.
Argent fixes that. It augments the prompt with relevant context retrieved from external data sources at the time the prompt is being built.
So it fetches fresh info just before talking to the LLM.
Exactly. This gives the LLM up-to-date or private information to draw from. For you, the listener, this is huge. ARGA means your LLM can become your personalized research assistant for your own private documents, or your up-to-the-minute news analyst on current events, without just making things up or hallucinating.
That massively reduces the hallucination problem and makes them practical for real-world business.
Absolutely. It's transformative for enterprise use cases.
So to make RAG work well, you obviously need to retrieve the right snippets of information. How is that usually done?
Yeah, retrieval quality is critical. You can use basic methods like lexical retrieval, just looking for overlapping words, maybe using something like Jacquard's similarity, or more sophisticated methods like TF-IDF, which weights words by importance, rare matching words count for more.
Giving more weight to the less common, more specific terms.
Right. And now there are even more advanced semantic search methods using embeddings, which capture meaning rather than just keywords. Getting the retrieval right is a huge focus area in our RAG systems.
What about really long documents? LLMs have that context window limit. They can only read so much text at once.
True. The context window size is a major constraint. For very long documents, summarization becomes essential before you even feed the context to the main LLM.
How do you summarize effectively for this?
You can use hierarchical summarization, summarize individual sections first, then summarize those summaries to get chapter summaries, and so on until it fits. Another technique is specific summarization, where you explicitly tell the summarization model why you need the summary, what the final task is, to ensure the condensed information remains relevant to your ultimate goal.
So summarizing with the end goal in mind. Okay.
Yeah.
Once you have all these pieces, instructions, user requests, static context, dynamic context, and RAG, you need to put them together. Prompt assembly.
Yes, building the anatomy of the ideal prompt. It's about thoughtfully combining all these elements, the boilerplate instructions, the user-specific query, and all that supporting context you've gathered.
Is there a best practice for ordering things, especially in long prompts?
Well, one useful technique for longer prompts is the sandwich technique.
The sandwich technique. Sounds tasty.
Maybe. The idea is you put the most important instruction or question both at the beginning and at the very end of the prompt, effectively sandwiching the context in between. This helps remind the model of the main goal, especially if there's a lot of text in the middle.
Refocusing its attention. Interesting. And you mentioned position matters generally.
It does. Information closer to the end of the prompt often has a stronger impact. This is sometimes called recency bias, or related to in-context learning.
So the last thing it reads sticks better.
Often, yes, but there's also sometimes a sort of valley of meh or mid-prompt fade, where a context buried deep in the middle of a very long prompt might have less influence than stuff at the beginning or end.
Huh. So the middle gets lost sometimes.
It can. It's a reminder that LLMs aren't perfect linear readers. You also need to think about elastic prompt elements.
Elastic elements.
Yeah, having different versions of your prompt components, like a short, medium, and long version of your instructions, or context summaries that you can dynamically swap in and out to make sure the final assembled prompt fits within the LLM's token budget for different situations.
Adapting the prompt length on the fly. Clever.
Now, all these techniques are great for building powerful applications, but like you said, LLMs are probabilistic. They make mistakes.
They're not perfect?
Not at all. So constant evaluation is absolutely imperative, both before you launch your application and continuously after it's in the hands of users. You need to know if it's actually working well.
Right. So how do you evaluate? What are the main approaches?
Broadly, you have offline versus online evaluation. Offline evaluation is about testing new ideas or prompts using simulated data or predefined test cases before users ever see them.
Like running tests in a lab.
Exactly. For example, if you're building a code generation feature, you'd check offline if the generated code compiles and passes existing unit tests.
Makes sense. And online evaluation.
Online evaluation is about gathering feedback from real users interacting with the application in production. This can be direct feedback, thumbs up, thumbs down buttons,
Okay.
or it can be implicit indicators. For GitHub Copilot, a key metric is the acceptance rate. How often do developers actually keep the code suggestion? For a scheduling assistant, you might track whether it successfully created the calendar event the user wanted. The key is to measure what actually matters for user productivity or success.
Measure the real outcome.
And what's fascinating is that you can even use LLMs to help evaluate other LLM outputs. This is sometimes called LLM as judge.
Using an LLM to grade another LLM.
Sort of, but
Yeah.
you need to guide it carefully. There's a framework called SOMA assessment. Specific questions, ordinal scaled answers like rate from 1 to 5, and multi-aspect coverage evaluate on accuracy, relevance, tone, etc.
Soma.
And a key trick is to frame the prompt so the LLM thinks it's evaluating a third party's work, not its own or a direct competitor's. That helps get more objective feedback.
Avoid bias. Clever. And of course, there's standard A/B testing.
Absolutely. A/B testing is the gold standard for learning from real users. You ship 2 or more alternatives, maybe prompt A versus prompt B, or system A versus system B to different segments of your users.
And see which performs better.
Exactly. You track predefined success metrics like average rating or acceptance rate to see which version wins, but you also need to watch guardrail metrics, things like error rates, latency, or user complaints to make sure your improvement in one area doesn't break something else.
Don't improve accuracy, but make it super slow.
Precisely. And finally, for really advanced systems, there's a concept called reflection.
Reflection, like reflection.
Spelled differently, but similar idea. It allows an agent or LLM system to review its own past actions and outcomes, for example, analyzing why the code it generated failed a unit test, identify the likely cause of the error, and then reattempt the task, using that reflection to guide its next try.
So it learns from its own specific mistakes on the fly.
Yes. It's a form of self-correction. It obviously requires more compute time because you're potentially running the task multiple times, but it can significantly improve results on complex tasks by enabling this iterative learning loop.
That's incredibly powerful. It feels like we're getting closer to systems that genuinely learn and adapt.
We really are, and as we look ahead, the pace of change in this field is just relentless.
It feels like new models, Llama, Claude, Gemini, are popping up constantly.
They are, and the capabilities are improving rapidly. One of the biggest pushes right now is towards multimodality.
Meaning, Models that understand more than just text.
Exactly. Models that can process images, maybe even video and audio as part of the prompt alongside text. Think of the latest versions of GPT-4 that can see.
Right. How does that change things?
It massively expands the LLM's understanding of the world. It can help with spatial reasoning, understanding social cues from images, physical common sense, things that are hard to grasp from text alone.
So what's the prompt engineering lesson there?
Well, for now, it's often about including only the relevant images and clearly framing them with text, telling the model what to look for or how the image relates to the text, often following common formats like embedding images within Markdown.
Okay. And what else is on the horizon for training and models?
We're seeing traditional benchmarks getting saturated, models are acing them. So researchers are developing new, much more challenging tests to really push the limit.
Raising the bar.
Yeah. And we're seeing creative training approaches like knowledge distillation. This is where a large, powerful teacher model trains a smaller student model to mimic its outputs, specifically its probability distributions over
Why
tokens.
do that?
It allows you to create smaller, cheaper, faster models that retain a surprisingly large amount of the teacher model's capability, maybe with only a slight hit to accuracy. It makes powerful AI much more accessible and deployable.
Distilling the knowledge into a more efficient form. Cool.
And the overall trend is moving beyond simple text completion or even basic chat towards more complex conversational agency.
Agents that can make decisions and use tools, like we discussed.
Right. And even beyond that, towards workflow agency. This is where LLMs can orchestrate complex, multi-step tasks involving multiple tools and potentially even human intervention points. Think of that Shopify plugin promoter example where the AI could manage an entire marketing campaign workflow.
From goal setting to execution across multiple steps.
Exactly. It's about managing entire processes, not just single interactions.
Wow. What an incredible journey we've taken today. We've really unpacked how prompt engineering transforms these, well, fundamentally text completion engines into incredibly powerful and versatile tools.
Yeah, we've seen how these advanced techniques let LLMs reason through complex problems, interact with the real world using tools, and even learn from their own mistakes through methods like reflection.
It's come so far, so
It
fast.
really has. So what does all this mean for you, the listener? If LLMs are fundamentally pattern matching engines, learning from this enormous ocean of human-generated text, and prompt engineering is essentially about shaping our input to better match those learned patterns.
Uh,
Consider this. What new patterns are we as humans inadvertently creating right now in the vast online discourse, in our code, in our writing, that will fundamentally reshape how the next generation of LLMs think and interact with our world?
huh. That's a deep thought. Our
Yeah.
current online behavior is actively training the future AI's baseline reality.
Exactly. How will this ongoing massive conversation between humanity and AI evolve? And what surprising emergent behaviors might we see next as these intelligent systems not only learn from us, but also inevitably begin to shape our own communication patterns in return?
It really is a conversation that's only just beginning, isn't it? Lots to think about there. Thanks for that incredible deep dive.
My pleasure. It's fascinating space.